Alright, starting chapter 6. 6.1 is graphing quadratic functions. A quadratic function is described by an equation of the following form. F of x is ax squared plus bx plus c, where a is not 0. So but all that means, where a is not 0, is that this will have a coefficient. Now it can be 1 or any other number. It's just not 0, because if it were 0, then this term would go away, and we would be left with just a line. So this first term is called the quadratic term. The next term is called the linear term. And the last term without the letter x is called the constant term. So that would be just a number. The graph of a quadratic function is called a parabola. Okay, one way to get the graph of a parabola is to use a table of values. So we're going to start back like we did in grade school when we were graphing lines and just create a table of values. So if we want to graph x squared minus 4x plus 2, we can use a table of values. Now remember, in grade school you could put any numbers you wanted in your table. So we're going to do just like we did in grade school and use these 5. Now if we plug negative 2 in for x, what do we get for y? So negative 2 squared is 4 minus 4 times negative 2. That's a negative times a negative, that's 8 plus 2. So I'm just plugging that number in and I get 14. If you plug negative 1 in, negative 1 squared is 1. Negative 1 times negative 4 is plus 4. Plus 2 is 7. If you plug 0 in, you will get 2. If you plug 1 in, you'll get negative 1. And if you plug 2 in, you get negative 2. So you're just going to do all of that work. Alright, now let's graph these points on a graph paper. Okay, and so negative 2, 14 didn't fit. So negative 1, 7, 0, 2, negative 1, or 1, negative 1, and 2, negative 2. Now this graph we know, because it's x squared, is supposed to be a parabola. And a parabola looks a lot like a U. So this graph needs to come back up on this side. So our table of values is not big enough. So we need to add to the table of values. So I'm just going to simply add a little bit more to my table. Again, if I put 3 in, 3 squared is 9, minus 12 plus 2 is negative 1, and if you put 4 in, you get 2. So if we plot those 2 points, you can see that it starts to go back up. So then you just draw your graph, and you get what looks a little bit like a U. Now it's not a V, it's a nice smooth curve, so it's all rounded. It doesn't make a V and go straight. So I call those U-shaped. Alright, it would be always nice to know this middle value. This we're going to call the vertex. If we had known that point first, we would have known we needed to go up this way and up that way. And that will help us make our table of values better. Because you know it's going to go on both sides of the vertex. Alright, for your homework they're going to ask you 3 questions. Okay, they want you to find the y-intercept of the graph. So again, that's where it crosses the y-axis. So you're thinking, okay, I have an x and a y-axis. It's going to cross this y-axis somewhere. Okay, so maybe it goes like that. Okay, so we're talking about this point right here. Well, anything on the y-axis, you know x equals 0. So all you have to do is plug 0 in for the x up here. And what will always happen is these 2 terms are going to turn into 0 because you're multiplying. So our y will always just be this number out here. So that will help us graph the problem. Alright, we want to know what the axis of symmetry is. Now the axis of symmetry is an imaginary line, so they usually make it dotted, that goes right through the middle of our parabola, where you can fold the parabola in half and it would be symmetric over that line. Okay, and that's always going to be y equals the opposite of b over 2a. So again, you want to call that the opposite of b over 2a. This isn't something you need to memorize, and you'll see why as we go along. Alright, finding this vertex point. Where is it? The bottom of the parabola? Okay, or it could be the top. Well, we first want to find that point, so that's going to be a point xy. Well, to find this x part of this, You just need this opposite of b over 2a. That'll give you that x point right there. And then I'll show you how to find the y. So if you look at the graph that we did before, x squared minus 4x plus 2. Now we've already graphed the problem. Now they're going to ask you those three questions. Okay, the y-intercept is where you're crossing the y-axis. So if it's already graphed, you just name that point. 0, 2. The equation of the axis of symmetry is always an equation. Again, it's this dotted line, and we've talked about these vertical lines. They're crossing the x-axis, so they're x equals. And where's it crossing? Well, it's crossing at 2. So you don't really need to know any formula for that. You can just look and see. Now, where's the vertex? It's this bottom point. And when you already have your graph, you can just name it. Okay? And so you know that the x value is at 2, and you know the y value is negative 2. Okay? All they're saying is that you can get that 2 using the opposite of b over 2a. And then if you wanted to get this negative 2, all you have to do is plug the 2 in, and that negative 2 is what comes out. So this is just out of that chart that we did at the very beginning. Then the last thing they're going to talk about is whether or not this function has a minimum value or a maximum value. This one has a minimum. It has a minimum because it has a low point, and then it goes back up. So this is how low does the graph go. It goes down to this negative 2 spot. So the minimum value you're getting from the y part of your vertex. Now if our graph had gone up like this, then we would say that it has a maximum value, and you would have to know where that point was to state the maximum value. So sometimes they will go upside down like that. Now, you have a choice. You can either do the graph first, like we did, using a table, and then answering the three questions. What I think is a little bit easier is to get an idea from the three questions first to help us graph the problem. Then we won't have to have such large charts. So that would be how I would try to do this. So again, I'm going to give you the big chart, but we're going to say let's try to answer some of the three questions first. Let's start with the vertex. Okay? So to get the x part of the vertex, we got to do the opposite of b over 2a. So the opposite of b would be negative 3 over 2a. A is negative 1, so that would be negative 2. So we have 3 over 2. Now you can change that to a decimal if you want to, 1.5. Okay, so if we put that in our chart, so now I have to plug 1.5 into here. Now understand that this says the opposite of x squared. So we're going to do 1.5 squared, get that answer, and then take the opposite of that. So 1.5 squared, using your calculator, is 2.25, and then we're going to take the opposite of that. So it's negative 2.25 plus 3 times 1.5 minus 1. And when you type all that into your calculator, you're going to get 1/4. Okay? Now, you at that point could go ahead and get all these table points. Okay, now why did they pick these points? Well, they went to the left of 1.5 and they used whole numbers. Then they went to the right of 1.5. Now this would take a lot of work to find all of these values. Okay? Now where else could you get this table of values? Well, you could certainly get it off of your graphing calculator. So if you type this into y equals on your calculator and hit graph, you would actually get the picture of what this is going to look like. And then if you went to the table of values, that could help you fill these in. Okay? I don't think that you need that much table of values. And so we'll talk about how to do it with a little bit smaller table of values. Okay? At that point, you could just plot all these points. Okay? Now, if we had just plotted this point, so this top one up here, which is what I would typically do, then I would say, well, I know that the axis of symmetry is this dotted line. So I could answer that question. That's an x equals, and where's that crossing through here? Well, if this point is at 1.5, then that has to be at 1.5. Now I know that if I find a point on this side of that dotted line, I can map it over and fold it over the dotted line to get the other side. So when I make my little charts, I just make small ones. Okay? And I would say if this is at 1.5, let me plug in 1. So we already did that over here, so I know that I get 1 out. So I would get this point, then I wouldn't put it in my chart, but I would say, well, how far away from my dotted line am I? Half of a step. So I know that if I map that over or fold that over the dotted line, I would land right on that spot. Then I would want to know what's the y-intercept. So we always want to plug 0 in for x. So when you're trying to find the y-intercept, we know that x is equal to 0. Well, if you just do that in your chart, it's going to help you graph it and answer that question at the same time. So if you put 0 in here, you get 0, 0, and -1. So 0, -1 is here. Fold that over. So you're 1.5 steps away from the dotted line, so you need to go 1.5 steps on the other side. And that would be good enough to make this graph. Okay, so I'm going to make these little mini charts instead of these great big huge charts. If you want to make the big charts, I would recommend you get those off your graphing calculator. And there's your little U. Okay, now again, I've answered all 3 questions before I graphed it. Okay, here we're going to graph it and then we're going to make sure we answer all 3 of those questions. I would have had these all answered already because I used them to graph my parabola. So it might be a little bit faster. Okay, now the last question, how are we going to get that? Well, we already did that when we were graphing, so you should already have that answer. Okay, notice this graph goes upside down. Okay, the reason it goes upside down is because of this negative sign right here. If that's negative in front of your x squared term, you're going to go upside down. So this is going to have a maximum, and so it's saying how high up does this go? And we know the highest point is 1.25. So it's a little bit on graphing parabolas. Now you might get some parabolas that are written in a different form. Okay, and so they're going to call this standard form. I might call this HK form, and you'll understand what H and K are and how this all works in great detail later in the course. Things to understand when it's written in this form. Again, this number, it could be a 1, but if there's a positive or a negative out here, the negative, okay, will determine whether you have a maximum or a minimum. A maximum means it's going to go upside down. A minimum means it's going to go right side up. Okay, so if it's positive, it's right side up. If it's negative, it's upside down. Okay, if you look at this, you can see the vertex point. It's HK. Okay, now this comes from a parenthesis, so that says minus h. Well, it's positive h as the vertex. We've talked about things in parentheses. When you take them out, you change the sign. The axis of symmetry you don't need to memorize, x equals h. If you do, that's great. But axis of symmetry, after you're graphing it, you can just think about it and get that answer. And for the y-intercept, you still just plug x equals 0 in. So you're still just doing your little chart, putting 0 in for x, and then solving for y. It's a little bit harder to do in this form. So let's take a look at an example in this form. This form seems to be a little bit faster, okay? So we can find the vertex. Well, first we'll say, well, it opens down because that's negative, okay? The vertex is HK. So this is H and this is K. So 5, 2. So you would graph that. 1, 2, 3, 4, 5, 1, 2. And you know that it goes down, so you might want to even remind yourself by starting your little parabola. Okay? Now the axis of symmetry, we know, is the dotted line that goes vertical right through that point. Okay? So that would be x equals 5. So now all I have to do is figure out where are some other points that are on this graph. Well, I know that I need to make a little chart, so this is my little mini chart. I know I want to put 0 in order to answer that question. So if you put 0 in for x, you get 0 minus 5. Negative 5 squared is 25. Okay? So the question is, how are they getting this negative 73? So we're plugging this in. I'm showing you all the work.